So what we're going over right now is complex numbers. Now, complex numbers are basically numbers that have two parts to them. So we have a real part and an imaginary part, like you see in this example up here. Now, the imaginary part stems from the I that you see here. Now, I is actually going to be equal to the square root of -1. So please keep this in mind when you are solving these equations. Now, when you are solving these equations, I never want to see a negative inside of a square root because this negative can actually be simplified. This square root of -18 can actually be simplified into the square root of -1 times the square root of 18. Now, from here, we know that I is equal to the square root of -1. So the square root of -1 actually turns into I. So this is actually I times the square root of 18. Now the square root of 18 can actually be simplified even more. The square root of 18 is actually 9 times 2. And since we know that 9 is a perfect square, this can actually factor out into 3 times I, because that's the square root of 9, times the square root of 2. And so this is the square root of -18 completely simplified. Now, as mentioned before, complex numbers have both a real part and an imaginary part. And we can actually graph these. So the real part will go graphed on what we call the real axis, which is going to be what you guys commonly know as the x-axis. So it's going to be 1, 2, 3, 4, 5. And then the imaginary part will go on the y-axis, 1, 2, 3. And so you have a dot here. Basically, you have this line. Now, they might ask you for the absolute value of a real number. If that's the case, then you go ahead and draw your triangle, and you think back to Pythagorean theorem. This is 3, and this is 5. And it should be true that a squared plus b squared is equal to c squared. So if they ask you for the absolute value, they're asking you for the value of this line right here, which you can find out by using Pythagorean theorem. You have a squared, which we're going to say 5 squared, plus 3 squared, which is 9, is going to be equal to 34. So this is actually going to be equal to the square root of 34, which you can't simplify, so that's going to be your final answer. Ladies and gentlemen, when you're adding and subtracting complex numbers, you basically just take the real parts and the imaginary parts and perform whatever operation they're asking you to do. So 5 minus -2, that will actually give me 5 plus 2, which gives me 7. And then -3i minus a positive 4i will actually give me -7i. And that's all you have to do for those. Those are actually pretty simple. When they're asking you to multiply, multiplying is actually pretty simple too. All you have to do is use FOIL method, or if you would like, you can use box method. I personally like FOIL, so I'm going to use 4 times -1, which gives me -4. 4 times -2, which gives me -8i. 3 times -1, which gives me -3i. And 3i times -2i, which gives me -6i squared. Now, if it stands true that I is equal to the square root of -1, then, and I'm going to write this in orange, I squared is equal to just simply -1. So if I'm looking to actually solve this out, yes, I can combine a few of these like terms, but I need to solve this first. This is actually equal to -6 times -1, which would just give me a +6. So +6 minus 3i minus 8i and -4. Now we can go ahead and combine our like terms. -4 and +6 combine into a +2, and -8 and -3 are going to combine into -11i. So from this you can actually see that we get one single complex number. Always remember to put your real part first and then your imaginary part. Now when you're dividing imaginary and complex numbers, it's actually very similar to multiplication, and you're going to use a lot of multiplication. So make sure that you really got this down before attempting to divide imaginary numbers. Now, imaginary numbers, when you're dividing them, you're going to multiply both the denominator and the numerator by the conjugate of the denominator. The conjugate just means that you're going to take your imaginary or your complex number and you're going to switch the sign in the middle. What do I mean by that? I'm going to multiply this by 1 plus 4i divided by 1 plus 4i. Now, using FOIL method, you should be able to get these answers. We're going to take 2 times 1. 2 times 1, that just gives us 2. 2 times 4i, that will give us plus 8i. 3i times 1, which will give us plus 3i. And 3i times 4, which will give us plus 12i squared. Now we just went over what happens when we have I squared, but let's do this bottom one first. 1 times 1 will give us 1. 1 times 4i will give us positive 4i. Negative 4i times 1 will give us negative 4i. And negative 4i times positive 4i will give us negative 16i squared. We can go ahead and simplify this into 12i squared is actually going to be just minus 12. And this is actually going to be plus 16. So we have this, these new values for this equation. Now we can go ahead and combine some like terms. 2 and the negative 12 will give us 10. Sorry, negative 10. And then that 8i and then that 3i will give us plus 11i. These 4's are actually going to cancel out, and what we're left with is 1 plus 16, which will actually give us just 17. Now we can actually go ahead and leave it like this, or we can separate it into fractions. Negative 10 over 17 plus 11i over 17. And this will be your answer. Now the final thing I want to go over, ladies and gentlemen, is this right here. This is actually what we call a sum of squares. So I know we had a difference of squares back when we were talking about factoring, and now we're going to have a sum of squares. Now this might not look like a sum of squares right now, but if I were to factor out a 2 from both of these terms, what I end up with is x squared plus 16, or 2 times x squared plus 16. That 2 is factored out. And this is actually a sum of squares. From here, ladies and gentlemen, I'm going to go ahead and basically follow the same thing that I did with my difference of squares. I'm going to take the square root of the first term and the square root of the second term. The square root of x squared is just x, and the square root of the second term is going to be 4. So I'm going to have x plus 4 and x minus 4. And the only difference is that since this is a sum of squares and not a difference, I'm going to add an I to the 4. And there you have it. That is the sum of squares. This is basically all you need to know about complex numbers. Let me know if you guys have any questions.